Hello guys, so today we are going to see the questions of amines and diazonium salt. And before starting with that, please note that if you don't know the byproduct and if you write the product, then also you will get full marks. So please note that if you don't know the byproduct, write down the main product and you will get the full marks. See the first question, complete the following reaction. Aminoethane plus chloroform plus strong base KOH, potassium hydroxide. When they react with each other, they will produce an isocyanide, which is ethyl isocyanide. Byproducts are KCl and water. Whenever hydrogen and oxygen is there in reactant side, you have to write water on product side. K plus, which is left, will go with Cl minus to give another byproduct KCl. And our main product is ethyl isocyanide. Then see the second reaction. Second reaction is the one when aminoethene is treated with nitrous acid, and in this reaction what happens that aliphatic primary amines when react with nitrous acid in cold condition, means 0 to 5 degrees Celsius, they first produced as a diazonium salt, and then that diazonium salt is again get decomposed into an alcohol. So you have to write down the final product. No need to write down the intermediate. Intermediate is diazonium salt. So when aminoethane is treated with nitrous acid, NaNO2HCl 0 to 5 degrees Celsius under cold condition, will get ethanol as the final product. Byproduct are again water, H and O are on reactant side. So you have to write H2O on product side, and nitrogen gas is released in this process. Third reaction and first reactions are same. Here aniline is there, and in first reaction aminoethane is there. That's the only difference. Chloroform KH, it will also give isocyanide. Byproducts are also same. Then last reaction, aminoethane plus acetyl chloride, Cl minus will combine with H plus, HCl will go out, and remaining thing we have to write as it is. So C2H5, then NH2 will become NH, one of the H is lost with Cl, and NH will attach to COCH3. So NHCOCH3. If you want to spread this, we can write like this: C2H5 NH, C double bond O CH3. Okay, both the products are correct. Whichever you feel better, you can write that. So these are the four questions. Then let's see the next one. Complete the following reaction. Nitrobenzene plus hydrogenation reaction, reduction reaction. In the presence of palladium, carbon and ethanol as solvent, it will reduce nitro group to NH2. So it is a reduction reaction. Palladium and carbon catalyst are used and ethanol is solvent. Reduction of nitrobenzene to aniline. Next is again a reduction reaction, but here we are using different catalyst. LiAlH4, that is lithium aluminum hydride. So two hydrogens will go to this carbon and will become CH2. Two hydrogen will go to N and it will become NH2. So ultimately we are getting a propane amine from ethyl cyanide. Next is Hoffman rearrangement reaction or Hoffman bromide degradation reaction. So amide is used. This is benzamide. Benzamide with bromine and KOH, strong base. Uh, Ultimately we'll get aniline. So you have to remove this C double bond O part. Remove this C double bond O part and you will get the main product, that is aniline. Mechanism is not there in your syllabus. K will combine with Br to give KBr, and H and OH will give water, and potassium carbonate is the another product obtained. The next reaction is direct reaction, nucleophilic substitution reaction at high temperature and high pressure. Chlorine is replaced by NH2. We are getting aniline from chlorobenzene. So these are the four reactions. Next is complete the following again. Diazonium salt is treated with this compound in the presence of NaOH, and this is azo coupling reaction. NCH3 twice is electron donating group, and when electron donating group is attached to benzene ring, this N2 will not go out, it will form a azo compound. So that's how that diazonium salt is remain there, and it is a dye. Yellow color dye is obtained in this case, and this reaction is called as azo-coupling reaction. Next reaction, aniline to fluorobenzene, NaNO to HCl will give the this bad leaving group will get converted into good leaving group, that is diazonium salt N2 plus Cl minus, and then that is treated with HgF4 fluoroboric acid. So N2 plus Cl minus is good leaving group and it is replaced by fluorine, and ultimately we are getting fluorobenzene. Byproducts are BF3 and N2. Next is third one, paranitrotoluene Sn plus HCl will give reduction reaction, NO2 is reduced to NH2. Next up is aniline is again treated with NaNO to HCl 0 to 5 degrees Celsius. NH2 is bad leaving group, it is getting converted into good leaving group, that is N2 plus Cl minus, and it is replaced by iodine of Ki, and ultimately we are getting iodobenzene from aniline. Nitrogen, N2 gas and KCl are the byproduct obtained. Next, complete the reactions are similar to the earlier one. First example is same. Sn plus SnHCl will undergo reduction of NO2 into NH2, same product, same reaction. Second is aniline plus HCl plus HNO2 0 to 5 degrees Celsius. We are getting a diazonium salt N2 plus Cl minus. This is there in preparation of diazonium salt. Third and fourth reactions are same. Aniline will give iodobenzene, NaNO to HCl 0 to 5 degrees Celsius, and Ki. It will give iodobenzene, N2 plus N2 gas and KCl. Fourth is also same. Aniline and NaNO to HCl will give diazonium salt. Bad leaving group is getting converted into good leaving group, and with fluoroboric acid